we streaming? Could we be? Never. Never. Let's just check that all the shenanigans is working properly. Can I click my record button? Yes, I think I can. Wonderful. Good day to you wherever you are. Good morning, good evening, good night, good afternoon. It is afternoon here in Al's Geek Lab territory, and I wanted to just try another live stream. Sometimes they work out fantastic. Sometimes we have lots of people in the live chat, and they're always good fun. But I'm basically going to record this and turn it into a real video, and I'll post that up on the YouTube channel probably tomorrow. So that's all good. And obviously I'll post it up on Patreon first. So if you guys are not already Patreon followers, then get me over on Patreon. Patreon.com/Al's Geek Lab. Now, what are we going to talk about today? Well, I thought this was quite nice. Microsoft have released 6.5.02 Basic. So I've decided to make a little script and show you guys what that's all about. So yeah, whilst some people come into the live stream, I guess this is, you guys get to see me in kind of real life mode doing what I do. I sometimes make a proper script for things, and I kind of go, okay, this looks about right, and then sometimes it looks absolutely terrible, and then I get inspired, I write stuff down, and this is kind of my workflow. So I think some of you have probably never seen my workflow. Certainly people on YouTube probably haven't seen my workflow. So if you've ever been interested in kind of what the behind the scenes looks like, then this is it. So I am gonna just do a little bit of checking of things, just make sure everything is working here, and see if this is all going on to the channel properly. So excuse me just a moment whilst I... Yeah, here we go. Here it is. It says live. Yeah, I can hear myself. Yuck. All right, cool. All right. So if you are in the on the stream, then say hi. Pop a chat in on the comments, and we shall go through this together. Hopefully, I have tidied up my script sufficiently. But yeah, I thought I would just talk about Microsoft today. I don't usually talk about Microsoft much on my channel because Microsoft used to be the devil. Used to be. I said used to be. For a very long time, Microsoft were the devil, of course, because they were closed source. They didn't release anything to open source. They really kind of went against the grain for the world that I was involved in. I didn't like the fact that they were closed source, because I was like, well, if it was open source, everybody could make this really crashy, buggy, horrible software better. And back in those days, we're talking about Microsoft Windows 3.1 and Windows 95 and all the rest. It crashed a lot. So if you're not experienced in using Windows in those days, then you probably don't know what I'm talking about. Windows 11 and Windows 10, they were much, much better, much more stable. But back in the day, Windows software was not known for being stable. And so I kind of annoyed me. And then I became a Linux user and my life got better. Anyway, that's all ancient history, of course. So if you've just joined us on the stream, what I'm doing is I'm basically recording this live, and I'm going to read out the script. This is kind of a behind the scenes live stream. First time I've done that on YouTube. And yeah, so you get to see kind of like how a video comes together. So there'll be some rough edges, and I might say things again if I make a mess. I've got my water here, So if I make a mess, I will just repeat myself. And that's kind of how the videos come together. So I often say things wrong and I have to repeat myself because it sounds dumb. So I'm going to record this all. It'll go into one file. Then I go into post-process and edit everything. So with that said, let's get on with the show. Welcome along to Al's Geek Lab. I'm not even reading my script. Oh dear. Hello folks, it's Al here from Al's Geek Lab. Microsoft have just open sourced its 6502 Basic version 1.1. This is the same BASIC that powered early machines like the Apple II, the Commodore PET VIC-20, and the MOS CHIM-1, and more, as you'll find out in just a few moments. We're going to wander through its origin story, what makes the code special, and even have a little hands-on peek at the source code on GitHub. Now, if you don't know what BASIC is a high-level computer language. So high-level basically means that it's kind of like writing in English, or it's abstracted from the machine level quite a lot. It's easier to write code in. And this was all the rage when the microcomputer market kicked off in the late 1970s and the 80s. The BASIC interpreter was often the first thing that you would see when you switched on your computer, whether you had a Commodore 64, an Apple II, or a ZX Spectrum. Often the times you would open up your computer, you start it up, and it would say BASIC, OK, or ready, or something like that. That was BASIC. The language, the computer programming language. These days we switch on Windows and so forth. It does not look like that. There's no language there. It's a computer operating system. But in those days, we switched on the computers and they were in a programming language rather than an operating system. Sometimes these BASICs had little hooks that they were sort of pseudo operating systems, but actually not so much, not much. They were the bare bones, just enough to load some data off a tape or a disk, and that was it. Anyway, almost all of the early home computers had this BASIC interpreter. And today I'm specifically talking about version 1.1 of Microsoft's 6502 BASIC. It was so-called 6502 BASIC because that was the chip inside many early super successful home computers. Microsoft's 6502 BASIC was written completely in MOS 6502 assembly. MOS were the chip manufacturers. Now this was originally developed, Microsoft BASIC was originally developed in 1976 and it was carried on for 6502 in 1978. It's part of Microsoft's early BASIC family. In fact, BASIC was Microsoft's first product, starting with Altair BASIC for the Intel 8080 CPU way back in 1975. It was ported to various CPUs. The first version that we are looking at today has just been released on the internet for anyone to play with. This is version 1.1, which includes fixes to the garbage collector. This version was written by some guy, you may have heard of him. He's called Bill Gates, and also it had contributions by a Commodore engineer, John Fagans, in 1978. This GitHub release has been made under the MIT license, which is special because not only are you free to view, modify, and redistribute. This GitHub release has been made under the MIT license, which is special because not only are you free to view, modify, and redistribute, you are even free to build upon it. Let's have a wee look-see. So this is GitHub, github.com/Microsoft, so you know it's legit. And then it's basic-M6502, the M standing for MOS, I would imagine. Now, if we have a look here, I like this looks very ChatGPT written, but you can see it does have information that they believe, Microsoft believe, it's of historical significance. It said this basic interpreter was the software foundation that powered many of the most influential personal computers. Well, we've just talked about that there. Also says that it had cross-platform compatibility, and that was because it was available for a number of machines. I'll talk about that in just a second. And you can see the sort of development history in here as well. I'll come back to that, but it's really cool to see this here. And of course, like everything on GitHub, we look at the source code because that's the whole point of GitHub. And you can see here the full source code of 6502 assembly coded BASIC, all the way down here to line 6955. So pretty cool. You can see these different lines here: simulated BASIC for the 6502, Kim BASIC, OSI BASIC, Commodore BASIC. So these are multi-platform. Anyway, despite this not being Microsoft's first release of BASIC, the 6502 version helped anchor Microsoft's reputation in the home computer era. The 6502 BASIC, the MOS 6502 CPU was cheap, simple, and incredibly influential. The 6502 was the beating heart of the Apple II series of computers launched in 1977. The 6502 was the beating heart of the Apple II series of computers launched in 1977. The first Commodore computers, the PET, as well as the later VIC-20 and the Commodore 64, the Atari 400 and 800, the BBC Micro in the UK, as well as the Acorn Electron and Atom, as well as less common systems including the chipmaker's own machine, the Kim-1. Because of this widespread adoption of the MOS 6502 CPU, BASIC for the 6502 spread far and wide, and Microsoft's 6502 BASIC was arguably the most popular version of BASIC for the 6502. From a technical viewpoint, implementing a full BASIC interpreter in constrained memory, constrained CPU cycles, limited RAM and so forth forced clever engineering in things like floating point arithmetic, string handling, arrays, dynamic memory, and garbage collection, all in 8-bit limits, was quite the engineering feat. Before this official release of Microsoft's 6502 BASIC on GitHub, there were several unofficial copies reverse engineered code, preserved archives, and so forth, but this MIT licensed version removes uncertainty around legality, makes it safe for hobbyists, educators, and historians to use. Microsoft says build environments have been reconstructed by preservationists. They verified the source can still be reproduced on byte-exact ROMs, and Microsoft and other long-standing computer software companies have recently started this welcome trend of freely releasing their source code for posterity. Microsoft themselves, most notably, have released the source code for MS-DOS versions 1.25, 2, and recently version 4 on GitHub, as well as the MS-DOS-based GW Basic languages, and also some of the more slightly modern software such as the file manager WinFile from Windows 3.0 and most of the .NET framework components. Should have really shut my phone down there. My apologies. Now, where was I? I was going to show more of the GitHub repo. That's right. So yeah, I mean, the fact is that this is all inside this one file, and you can look at all of the code here as well as the comments, which I think is really cool because a lot of developers have different programming styles. And what I can see here is that unless these have been added on after the event in a sneaky way, nobody's actually told us, then basically Bill Gates and a few other people from Commodore have added on these comments at the time that this software was written. Now, that's pretty cool because a lot of people who write software aren't as good as this at commenting code. So this is pretty neat, pretty well documented code. I'd like to say this is not bad at all. This is good. This is real good. So what have we got here? Commit information. I think I was going to show there. Yeah, where's the commit information? Aha, here we go. Now, as I said earlier, the repository includes m6502.asm, the assembly language file. This one file is the entire code base for the 6502 BASIC. It's all written in assembly. These days, software is many, many times larger than this stuff, and it often sprawls over hundreds of files. So to see the whole program for the entire computer basically written in one file like this really shows the capability or the constraints of writing software back in the day. And as I said, as far as we know, this is the original handwritten style assembler comments, labels, and the main routines like floating point math, for example. I think it's fascinating looking over the commit information. Back in those days, there was no repositories like Git. The code would be saved to floppy disk or tape, and the file timestamps are reconstructed or preserved as being around 48 years old, and that's part of its charm. If you have a look at this, the original code commit, I guess, was 1976. You don't actually call it a commit because, as I say, there was no Git or anything like that. So the first version of the 6502 would have been around 1977. And you can see the version history, as they would have probably called it back then. So starts off in 76, goes 77, 78, all the way up to here. So you can see they've found some bugs and commented on all of these things, whether these were written by Bill Gates himself or a combination of people at Commodore, for example. It's quite likely that that's the case. But you can see here there was a serious bug in all versions. So they didn't notice this serious bug for quite some time, which is, yeah, pretty cool. Now, what did I say here? Reading my own stuff. Now, note that this code here is not the extended version of the 6502 BASIC, which shipped later with the Commodore 64, etc. Those versions added graphics and sound and hardware-specific features. This version is kind of like the core language. This is the one that was worked specifically with the CPU, but really didn't have the unique versions of all of those things like the sound and the graphics that came later. This is a very rudimentary version of the BASIC. Some of the features people associate with Commodore BASIC, e.g. the disk commands and so forth, are vendor-specific additions that were added, by Commodore. These are not core in this version of BASIC. Now, performance limitations due to hardware were also in here. Also, the code is in assembly language. Modern people reading it will need a bit of patience and some familiarity with 6502 assembly to fully understand what is going on. When you get into past all the comments at the start, there's quite a lot of comments, by the way, at the beginning to kind of talk about how it actually works, which is, again, quite nice. But you go in here, then you're starting to look at, proper 6502 assembly. It's somewhat readable, but as you get into it, you can see that these are all CPU level. They're all CPU level instructions. So this one here, for example, I'm just picking out of the blue, is to load information into the register A. I believe I'm not a 6502 assembly coder myself, but from what I remember from many years ago, this stores in the A register. This DEC means decrement, so decrement a value. BNA, I think, was break if not equal. I can't remember. These are all things that I have forgotten many, many moons ago. Anyway, so what's the point in this 50-year-old code? What the heck can you do with it? And why would you even want it at all? Well, I've got a few perspectives, depending on what floats your boat. Since you're watching Al's Geek Lab and you're far into this video already, I dare say that you're either a hobbyist or maybe you're looking at this from an educational or historic perspective. But I can think of a few reasons. So for hobbyists, I dare say you might want to actually try and assemble this code and run it on an emulator, for example, like the Apple II emulators. There's plenty of those out there. Or maybe you could build your own ROM image and stick it in a real machine that has the 6502 CPU. You can actually still buy the 6502 CPU, so theoretically you could even build your own 6502 machine and run Microsoft's 6502 BASIC on it. It's pretty cool. If you're also into the sort of newer shenanigans with FPGAs, perhaps you could burn it into an FPGA and play it with that. If you've got a broken down 6502 machine that's not really working, I guess you could do this as part of fixing it up. Anyway, all of this stuff is highly educational too. Reading the source code will teach you on how programming and languages and interpreters used to work, and it will show you parsing and memory management, floating point math, and tiny environments with hardly any memory. And it will give you an appreciation. It will give you an appreciation of how computers, even modern day ones, work at their machine level, at the core. And that sort of stuff is not taught enough these days, but it could be a really great history lesson too. And if you're into in-depth retro projects, you could even combine the source code with modern tools to extend it or port hardware-specific features, integrate with other vintage hardware. A lot of different things you could do. And of course, if you're just someone that's a bit curious, this is a great way to explore the history and to see the code that was written by Bill Gates and Rick Weiland in their early days. So Microsoft opening 6502 BASIC version 1.1 is actually a pretty decent gift to people like us that enjoy digging into the roots of computing. And I hope that once the once super closed source proprietary castle Microsoft continues its new track record of opening historically significant stuff up. I'd love to see Windows 3.1 or 3.11 or Microsoft 6.2, maybe even Windows 9X opened up someday soon. Anyways, since you're into the stuff, why don't you pop over and check out Al's Geek Lab on Patreon? The people that you're seeing down the screen right now did so, and now they're supporters. And for their support, they get early release, ad-free videos, and bonus content too. So check it out over at patreon.com/Al's Geek Lab. And don't forget, if you aren't already subscribed to the channel, then click that subscribe button now for lots more retro computing goodness. If you like this video, I'd also really appreciate a thumbs up too. It tells YouTube that I'm doing the right thing. Anyway, that's all for this video. I hope you've enjoyed it. Stick around, watch me on the live stream, and I'll do some other things maybe. But yeah, what else was I going to say? Oh yeah, thanks very much for watching, and be excellent to each other. I always say that at the end. I don't know why I didn't say that there. Anyway, did I miss anything else? Did I miss anything else? I don't think so. No, I didn't. Well, hey, that's a wrap, people. I maybe could show a few other things, but you know, this here is a picture of the ubiquitous Apple II, and I think maybe this was the machine. I mean, some could argue that there was the PET, there was the the TI-99 and so forth. But if you think about the trifecta of machines in 1977, the one that really got away with popularity was the Apple II, and this is what it looked like. This is the OG Apple II with this swinging bezel monitor here, and the two floppy disks drives, and this here, and the beating heart of this machine, of course, was the 6502 CPU. And of course, Microsoft made the made the basic for that eventually. I think initially Steve Wozniak, the other Steve, he was the one who wrote the very first basic interpreter for it, and that was called Integer Basic, if I remember correctly. And it was fine. It was good. It was plenty good to do what you needed to do, but it didn't allow. It was called Integer Basic because it only dealt with integers, and that's non-floating point values, numerical values, up to I think either 32,767 or was it 65535? Anyway, it was positive that or negative that, and that was it. No floating points. If you wanted a decimal something, I mean, it sounds crazy to think of that these days, but that's literally it. Didn't do floating point, and it didn't do a few other things. It was a rudimentary basic. So I think within a year or two, they had licensed Microsoft Basic back to Apple. And it wasn't called Microsoft Basic though, which is kind of strange because if you think about it, Apple were up here; they were the king of the crop, and Microsoft were just this small company really at that time. In fact, let me just see if I can find a logo. So this was like the next logo on, but the first logo of Microsoft was actually even more interesting. Let me just try and see if I can find it. I'm sure I had it around here somewhere. Maybe not. I don't know. Anyway, it was Micro Dash Soft. So it was Microsoft became one word later on, but the original logo and the original words themselves were actually Micro Dash Soft. So that's quite cool. But yeah, so Microsoft Basic was renamed AppleSoft Basic. So they kind of took the soft word out of it and yeah, called it AppleSoft Basic. But it was just the same version of Basic that we can see here. This was pretty much, there were additions for the AppleSoft Basic. I think they added on graphics routines and so forth, but at its core, this was the software, the code that it was involved. And so yeah, there was just some add-ons for the GR modes, for graphics modes and so forth. So that was kind of how it all began. I don't think we've got the source code for AppleSoft Basic. I don't think that was released, but yeah. So there's the example right there of them using the old dash in their name, Micro Dash Soft, which is really interesting to see. And I think if we go through some of this, I think what am I looking for? Yeah, so this is cool. A little bit of information about the actual commits, and then lots of documentation. So this comment here that obviously it would be interesting to find out which assemblers could actually assemble this. So it just says on the website it works with contemporary assemblers. Well, there was quite a lot of assemblers, so which ones would actually work here? So there's nuances which would specifically work with some of the compilers, but not all of the compilers. Anyway, so there's lots and lots and lots of comments at the beginning of this code. I mean, it looks very tidy. Yeah, look at that. That must be what, 600 lines of just information about what the code is doing, which is interesting because they probably didn't expect that many people to read this. So it's almost like they have added this in after the event, but that would be a very cynical view of mine to think of, right? But it says, M6502 basic configures basic as follows: 0 page, and then you've got starts off with a jump to ready, which is the text that comes up saying ready, and all this sort of stuff, which is all kind of kind of codey, so forth. But there's lots of little interesting Easter egg kind of stuff. In fact, I think I looked up a little bit about Easter eggs here. Yeah, so if you have a look here, Bill Gates personal Easter eggs in 8-bit BASIC. So if you type wait 6502, 1 into Commodore PET BASIC, which is pretty much the BASIC that we saw, just slightly newer, 1979, it will show the string Microsoft at the top left corner of the screen. And I think this was maybe a little bit cheeky because you see they've overwritten the word Commodore. So this is what you would see when you started up your Commodore PET, right? It would say Commodore BASIC, and that's it. And then you type in wait 6502, and it would overwrite that with Microsoft. So they were being a little bit cheeky, but it's maybe like because they were told by Commodore, look, it's not going to be called Microsoft BASIC, it's going to be called Commodore BASIC. So they maybe felt a little bit miffed by that, but obviously they were paid for it, so you know. But anyway, it said Microsoft at the top left corner of the screen. Legend has it that Bill Gates himself inserted this Easter egg. I believe that has been confirmed semi-recently by Bill himself. He had an argument with Commodore founder Jack Tramiel, just in case Commodore ever tried to claim that the code wasn't from Microsoft. Yeah, no, that's fair cop, actually. So that's cool. What else? The whole story sounds familiar to Apple embedding a stolen from Apple icon into the Macintosh firmware in 1983, which is quite clever as well. So yeah, this is quite a nice article here on pagetable.com if you're interested in having a look at this. 76 MOS technology introduced the KIM-1. Now this board here, I'm just going to say hi to the people on the stream. This is the version. Hi, friendly neighborhood Jesus freak. Found the stream late. No worries, don't worry about that, because if you go back to the channel tomorrow, I should have this up on the channel, the recorded version. I'll probably make it a lot nicer. This is just me riffing off the actual. This is kind of like a background, kind of behind the scenes. What I do on Al's Geek Lab when I'm recording the actual thing. So it's kind of like a little Easter egg of its own, I suppose. It's like me doing what I usually do, but not on camera. Anyway, in 1977, Microsoft changed the 6-digit floating point to support 9 digits and included actual error strings instead of 2-character codes, while leaving everything else unchanged. The 6502 machine, basic ROM, needed more than 8K anyway. So, yeah, that was the original kind of KIM-1. So that was the first machine that ever had the MOS 6502. So it was just basically a hobby machine. It was made by the same people that made the 6502 CPU. And that's what it looked like there. It's a single board computer, and you didn't even have a keyboard on it. You had this little numeric pad, and you would just basically type in assembly routines or machine routines basically into this. But I believe you could add on things later on, such as keyboards and screens and all the rest. There was an ASCII terminal or video monitor could be used through the serial port. So that's when you would basically be able to use the Microsoft BASIC on that. Friendly neighborhood Jesus freak says this is the version in that source drop as evidenced by the string Commodore BASIC. Yes, it is. So you didn't see that when I showed that I think right near the start of this video. But near the bottom of the source code, I think that says right down here. Yeah, that's it. So line 6937, it's basically saying if this is defined as 3, then print Commodore BASIC. So you could multi-tenant this BASIC, basically, depending on the machine that you compiled it for. And those flags for compilation are right up at the beginning. So you can see here, you've got 5 STM. I don't know what STM was. 4 is basically the Apple II. 3 is a Commodore system. 2 is OSI. 1 is the MOSTEC Kim, the thing that I just showed you, this thing here, and PDP simulating 6502 is awesome. So the very first time that Microsoft, so that would have been Paul Allen and Bill Gates, wrote their basic interpreter, they built it for the Altair 8080, which is basically the first home computer, the first hobbyist home computer. And that came out in 75, as I said earlier on when I was recording the video proper. And basically the way that they coded it, because they didn't actually have the Altair themselves, they did not have the machine they wrote BASIC for. They were like, this is cool, we've seen it on popular electronics, it uses this Intel 8080 processor, we think we know how it works, but they didn't actually have the Altair, and they didn't have an Intel 8080 processor. They just read how to process, how to write code for that CPU. So what they did is they used the only computer I think they had access to, which was a PDP-10, and they wrote the source code on a PDP-10, and I think they actually just wrote it on a paper at one point, and then I think they put it onto tape, and then took the tape with them to Albuquerque, I want to say, and they just ran the tape and hoped that it would work. They didn't even fully test it, and of course it worked, which is insane. Imagine if it didn't work. Then there would have been no Microsoft, probably, because the guy at MITS, can't remember his name anyway, the guy at MITS would have probably gone, who these guys are, just kids and they're losers and their code doesn't work, so goodbye. Anyway, that's kind of how it all started. They wrote it on a PDP-10, so it's pretty cool. So lots of stuff like that. So you just from me scratching through the source code in a few minutes, I can see this is, there's lots of really interesting things to find out. And of course, there'll probably be a few Easter eggs as well. But the comments are very helpful in telling you what the code actually does. And I think 6502 itself is a very nice, clean, simple instruction set. It's not what they, I guess, fully call RISC, which is reduced instruction set. But if you compare it to x86, the Intel instruction set for like the common day x86, that is what's called CISC, or complex instruction set. The complex instruction set is complex for sure. Like the whole way that you code in x86 is massively more complex than how you would code for 6502. And they were just two different approaches, really. They weren't necessarily the best way or the worst way. It wasn't like that. They were just two different ways. And now when you look back at the two, you go, wow, coding for 6502 was so much easier. The code itself was just, there was less instructions. There was much more rudimentary. There were things that really were a lot more difficult, because things like floating point math there was no instructions for floating point math. It had to kind of be, there wasn't an instruction that just said, some floating point thing. You had to basically do the math to make floating point new numbers. Like you had to hold the pre numbers, like the initial numbers before the floating point in a register, and then other numbers after the floating point in another register, if that makes any sense. So it's pretty wild that that it was so simple, but the simplicity of it makes it a nice, easy assembly language, or a nice, easy machine language to start your journey on writing a source code for an assembler or a CPU, even if you wanted to go right down to that sort of area. So anyway, I've been Al. I think I'm going to end the stream at 40 minutes here. If you've watched along, thank you very much for watching along, and I will see you hopefully in Patreon. Actually, come along to Patreon. patreon.com/alsgeeklab, or you can check us out on Discord. Let's have a look at Discord. Yeah, there's lots of lovely people on the Discord as well. So I will let you go, and thank you very much for watching. See you on the YouTube channel probably tomorrow. Bye for now.